Okay, so the UI is vibe coded basically. So I generated all the data, and this the UI I vibe coded it out of it. So it's a very interactive UI. So this is it's visible, right?
Yes. Yes.
Okay. So if I start it, like the time step goes from 0 to 219 or whatever the embryo is. So so it shows the mitosis as well, like how the cells are uh, changing, and we can zoom into them as well, like this. So as you can see over here, I can just pause it. So over there, there's a red boundary on this specific cell. So with that means that the model couldn't predict it properly. Like on over this cell, there's a boundary, like a red boundary against it. So that means so if I click on that cell, you can see here that so it predicted that this cell was actually a Farnex, but its actual true fate was a neuron. And so the verdict was missed, and we can also see the parent and the time step at which the cell existed. And we again start like over here. We can also, like, if we just want to see the neuron cells, we can also uh, see that, like, these are only the neuron cells, and we can like categorize those according to what cells we want to view or analyze. So you can see like most of them are predicted, but there are like 30% of them which it's a miss basically. So the model predicted that this was a muscle, but it's actually a germline. So this is also there. So after that, these are the explainable things. So which features drive each fate? Like for the neuron, the coordinates basically were the most useful in understanding if the fate was neuron or not. The blot was not useful at all. Like it's basically the fluorescence of the like the capture fluorescence when it was captured. So it was not that useful. So that's why it's completely zero, because it's not. It couldn't correlate at all with why the fate is predicted that way. And next we have the size and all. Like it's different for different different one of the like uh, part of the cells. And we also have the tissue to tissue contact, like the contacting with each other, like neuron is connected to 1067 neuron cells. And we can see the model performance over here, like how it increased. Like it was like 40% when I started it, and it increased to around 65%. So maybe if I can run it for like 100 epochs, maybe it will go to like 60, 75 or something. So that's it. Like it's very interactive as well. If you want to check one single cell, we can also check that. We can hover over it, and yeah. So the SGL is the model predicted this I think very nicely. Other than the other one, like if it was mutated or non-mutated, the sulfate went well because the labels were pre-decided and we had actual data onto it.
Right. Yeah, that looks good. So this can be. So you have tissue fates, and of course the fluorescence didn't predict that because they're all the. I mean, the markers aren't specific to the tissue fate. It's just.
Yeah.
Yeah, but then you have. Actually, it brings up a good question. I wonder if maybe for future work, we could have like a gene expression data set underlying it and plug those in for each cell. Or I know there are data sets where you can do that, but it would be interesting.
Okay.
And then this is nice, this map. So these are just the different cells, and
Of a specific embryo, then we
yeah,
can run
yeah.
it again for a different embryo.
You could do this for any one of the specific embryos, or just
Yeah,
okay.
we can do it for any of them.
Oh. Um, could you like so? Could you reconstruct the graph here? I mean, could you have like a way to plot the graph and then explore? Like what I'm thinking about is there different parts of the graph, like you have rich
So
club
basically,
neurons, or
if we select a
yeah.
specific fate, then it will like put on a graph as to how it led to that fate. That kind of a graph, is it?
Okay,
Or
yeah.
do we want a testing accuracy type graph, like evaluation type graph?
All right. Yeah. We'll have to take a look at that some more. It's definitely good. Yeah. So you vibe coded this?
Yeah, the UI, yeah. I gave
Oh,
it like I
nice.
wanted this way and everything.
It's nice. Yeah, that looks good. Um, do we have any questions for Barshan on that? That's nice work. Thank you.
Yeah, thank you. I'll upload this this week.
Okay.
This
Yeah.
UI with
So
the data, new data set and everything, the links and everything.
okay, that's good.
Yeah.
Yeah, and then as for like your up, so that's your update. That's what you've been doing, obviously, and working with the new
Mhm.
data sets. What are your plan? Like, what's your plan for the next week or next 2 weeks?
That one thing I was thinking, like if we can just select a fate and then just like how in Napari they used to like put a path of a cell and how it led to that. Like we can highlight a path and how it led to it. Something like that was explainable. I would try to look into that. Like this is a simple model running in due to the labeling.
Yeah, yeah, it just has the labeling and some of the other data underlying it. But I mean, you could replace that with sort of the information about the lineage tree. I mean, I know you have the
Hmm.
nomenclature, but the actual connections, like um, this cell is the mother of these daughter cells, or just like a
Yeah,
network relation. Yeah.
the parents are also mentioned in this. Like I select a specific cell, the parent will also be mentioned over here,
Oh, okay.
like, which was the previous parent.